Okay, this video is for my pre-calculus class. This is number 2 on our modeling with exponential and power functions lab. So I'm going to try to do a couple more questions on this one. So I have 2 points going on here. I have negative 6, 36 as my first point, and my other point is negative 2, 4/3. Okay, so what I'm going to do, like I did the other one, is I'm going to first find a model of exponential of y equals ab to the x, and then I'm going to do the power function model is y equals kx to the p to find the formula. Okay, so the first one is, remember these are my x's and y's. I'm going to start out here with 36 equals ab to the negative 6, divide, and then I'm going to put my other point in, 4/3 equals ab to the negative 2. Thanks for playing. So 36 divided by 4/3 comes out to be a nice 27 equals, and then if I'm dividing, that's going to be b to the negative 4. Okay, I'm going to raise both sides to the negative 1/4 so I can get b. And when I do, I get b to be 0.438691. Now I know y equals a 0.4387. I'll just round it to that, okay, is my x. And then I'm going to plug in a point, and so I'm going to plug in my x and y of the negative 6, 36. So I have 36 equals a 0.4387 to the negative 6. These are hooked to the a by multiplication, so I'm going to divide 36 by 0.4387 raised to the negative 6. And when I do, I get a to be 0.256599. So I'm just going to round a bit. So I have y comes out to be 0.257. I just rounded to here. And I got 0.4387 raised to the x. So there is my exponential model of those 2 points. Now we're going to do a power function model, and remember y equals kx to the p, so my variable x is down low. We're going to do almost very similar, I should say, it's not the same, but very similar. So I'm going to do 36 equals k. Now my x is down low, so the negative 6 is going to be here raised to the power p. Divide. Now I'm going to do 4/3 here equals k negative 2 raised to the p. The k's will now cancel out. And when I do 36 divided by 4/3, I get the same thing. I get 27 equals. Now remember, the powers are the same, so I can just divide these. This comes out to be 3 raised to the p. Now, here I look at this and say, oh, the p is my exponent, my power. So I'm going to natural log both sides and bring the p down. So I have the natural log of 27 equals p natural log of 3. And I'm looking for the power, so I'm going to divide by the natural log of 3. So p equals the natural log of 27 divided by the natural log of 3. And when I do, I get 3. So now I have, ready, y equals kx cubed. Okay, that's great. Now I want to find k. So I'm going to plug in, I plugged in the first point, negative 636. So I have right here 36 equals k, and negative 6 is going to go here, cubed. I'm solving for k. It's hooked by multiplication of the negative 6 cubed, so I'm going to just divide by that. And when I do, I get k to be negative 1/6. So my formula for my power function comes out to be negative 1/6 x cubed. Okay? Let's see if I can fit number 3 in here so you can have one more. Before I do number 3, I just want you to know number 4, this should be a positive 1/5. So if you're watching this video, please change that. And let's do number 3. Okay? So I have my 2 points, 1, 3/2, and 2, 3/8. And what I'm going to do is the same thing. So I have y equals ab to the x. So I'm going to do 3/8 equals ab squared, divide, because it's a ratio. And when I put in the other one, I have 3/2 equals a equals AB to the first. Then these cancel out. And when I do this, I'm dividing, so I subtract. So I have B to the first comes out to be, and 3/8 divided by 3/2 comes out to be 1/4. So that's nice. So B is 1/4, okay? So now I have Y equals A 1/4 to the X. So now I'm just going to plug in one of the points. I'm going to use 1/3/2. So I have 3/2 equals A times 1/4 to the first. And when I divide 3/2 by 1/4, I get A to be 6. So this one comes out nice. This actually comes out to be Y equals 6 times 1/4 to the X. So there's my exponential representation of those 2 points. Now I'm going to do power function, okay? So I'm going to do Y equals KX to the P. So I'm going to do the same thing. 3/8 equals K. The X is now down low, so that's going to be 2 raised to the P. Divide. I'm now going to get 3/2 equals K 1 raised to the P. Again, the K's will cancel out. Whoops, I didn't mean to do that. Let's try that again. The K's will cancel out. So again, when I divide 3/8 by 3/2, I get a nice 1/4 here, equals, and then 2 divided by 1 is 2 raised to the P. And what I have to do to both sides, you guessed it, I have the natural log to figure out what P is. So I have the natural log of 1/4 equals P natural log of 2. And then I'm going to divide the natural log of 1/4 by the natural log of 2. And when I do, P comes out to be -2. So now my equation so far is Y equals X, excuse me, I forgot my K, KX to the -2. And now I'm just going to plug in one of the points. So I'm going to do 1/3/2, the top point here. So here I'm going to put 3/2 equals K 1 raised to the -2. Divide 3/2 by 1 raised to the -2, you get K to be 3/2. So my power function comes out to be a nice one. Y equals 3/2 X to the -2. So I've got 2 and 3 in this video. I'll probably do another one for 4.